This is going to be a very short presentation about callback help, and this is basically a follow-up, a small follow-up of last session. Talk about asynchronous programming, and I decided just to give the talk because I worked on some asynchronous application using an event loop for almost 3 years, and I learned a lot during the process. So. No. The computer decided to sleep.
The fucking globe. Yes.
Okay, we're back. So, first, before we start, I'm just a Perl newbie, so I'm not going to talk much about Perl because, you have a chance to talk about things not related to Perl, so I'm going to use that opportunity. So some examples are written in some sort of pseudo-Perl, so if you see errors, well, it's because it's not Perl. And I haven't tried it. Also, I'm not using any specific library or event loop, I'm just using some sort of pseudo-code, which looks like Perl. And as I said before, well, this is basically a follow-up of Sawyer's talk in last session about synchronous programming, so I'm not going back on those topics. And finally, when discussing about asynchronous programming, I'm just reducing the field to using basically an event loop. So other kinds of asynchronous programming, threads, and other stuff right now. Okay, so I'm just going to start explaining what's the callback help. And for that, I'm just, let's talk a little bit about how the asynchronous programming world starts very simple, but it starts getting quite messy once you start just having a more complex application. So here's just the basics of asynchronous programming. So you have, for example, this fetch URL function. And this is the synchronous version, this is the synchronous version. So in the synchronous version, you basically just call that and just wait until, the network request goes and back. And then you have a content and you continue with your program. In the asynchronous world, well, you usually use a callback. And you see that immediately something changed. You have this final statement to print the end is actually executed before printing the content. And it's because the asynchronous program is using the synchronous program uses an event loop, and the event loop just takes care of that and just calls the callback whenever it's ready. So that's what we saw on the last presentation. So this is a very simple example with just one request, but let's see what happens when you start just decide to say, okay, let's write a web application using a synchronous program of this. So the problem with the synchronous programming, or just the thing with the synchronous programming, is that once you start doing something asynchronous, you have to do everything asynchronous. And that's why the reason for that is very simple. So asynchronous programming gives you, or an event loop gives you this kind of illusion of parallelism. So it's just like this. Here, there's no multiple Jackie Chun fighters. It's just one single Jackie Chun, but he's just spinning so fast that it gives you the illusion that there are many of them. And then this is basically how asynchronous programming works. You have an event loop who is just going from callback to callback, calling things very quickly and just continuing with the next one. The problem with this is if you, for some reason, one of these callbacks take a little bit more time than expected, well, what happens is this. You're screwed. For example, if you do any blocking operation during a callback, like a database call or whatever, or just a very expensive computation, you're stopping your entire program, and you're stopping other events from being processed. So what means is, what this means basically is that once you start writing asynchronous programming, you have to do everything asynchronous as well. Because you can't have the luxury of blocking at all, ever. Now, let's see some small recipes of different kind of synchronous programming combined using the same model that I show you with the callback to see why this is the callback. So I'm just taking this small example, which is how to make a boat in Minecraft. If you never played Minecraft, just play. In case you don't need that to understand this, basically to make a boat in Minecraft, you first need to get some wood from a tree, then to process that wood into some wood planks, and then use those wood planks to make a boat. The thing with this is that there are three different sequential operations. So to get the boat, you first have to get the wooden planks. And to get the wooden planks, you first have to get the wood from the tree. So you can just do this like in parallel or something. There are sequential operations. Now, in the synchronous world, this is just very simple and straightforward. You just basically have your wood, which is returning from the chop tree function, then process the wood and just return some wood planks, and then use call wheel boat and just get your boat, and you have your boat ready. But when you have an asynchronous program, you have to start just playing with your callback. So you start with the first callback, which is the one of the chop tree. Then you call process wood and just you pass another callback, and then you get your wood planks from there, and then you get another callback, which is the build boat. And eventually you have just your boat ready. And here you see how you start just, you see a transition from a very simple and straightforward way to read your program, very sequential, to something a little bit more messy, where you have some levels of indentation and some different scopes and functions. So this is just, here you see your program a little bit more hard to read. Now let's make a cake in Minecraft. So to make a cake in Minecraft, you basically take some wheat, some sugar, some eggs, and some milk. You combine them and you make a cake. Well, the interesting part of this is that these elements don't depend on each other. So you can get your milk independently of your eggs and independently on your sugar and so on. So this, you can eventually, if you have 4 friends, you can say each of them, okay, you get the wheat, you get the sugar, you get the egg, you get the milk. So you don't have to make it sequential. Now, this is the synchronous version of the same program. Here, well, you don't have a choice, you have to make it sequential because that's how synchronous programs work. And you first get the eggs, then the sugar, then the milk, then the wheat, then you combine them in a make cake function, and you have your cake. Of course, this is the point with the synchronous programming is just not to have to wait for each step to do things. So let's do it in some sort of synchronous version. And here things are a little bit more complicated because to make the cake, you have to first finish all these processes or these just operations before. So you have to get some sort of to get track of what's happening with all these different results. And only when you have all of them ready, you proceed to make the cake. And something just that makes this thing difficult is that with the synchronous programming, you can't actually predict which one is going to be the last one. So you have to just basically check on all of them. So basically, when you try to find a chicken to get an egg, so you have to check if you have all your ingredients. The same for the sugar, the same for the wheat, and the same for the cow. Now, this process all subroutine is basically checking if you don't have all the elements, just return, and if you do, just make a cake with those ingredients. And this is just start getting more complicated. In the first place, because each callback now has to just modify a state outside its own scope. You have to keep track of the sugar, egg, wheat, and milk processes outside the callbacks just to know when the last of them just finished. And when all of them are finished, you can just go and make your cake. So here is just, your program is not sequential anymore. Your program now is just kind of more twisted. And also it's modifying state outside the scopes of functions, so this makes things a little bit more complicated. This is why I was reading an article the other day why just callbacks are called like the go-to so far generator, because yeah, your program starts just jumping from one part to the other in some very hard to follow. Oh no, not again. Okay, so let's continue. And another problem which causes callback hell is error handling. So if you have just one single callback, you have to somehow find a way to handle errors that can happen in your operation. So here, for example, for the fetch URL, of course, a network operation might fail for a lot of reasons. Maybe you don't have your cable connected or Wi-Fi is down or whatever. So you have to somehow keep track of what to do if there's an error in your operation. One option is just maybe to pass an error argument to your subroutine and just control that in some ways, just like this simple example. But what happens when you actually have this chain of calls, and you start also managing errors in these callbacks, so you end up with this very messy code that it's kind of hard to read. And this is the previous example of just how to build a boat, but here just managing errors on each of these steps. And this is just very simple error management, because you're just basically printing an error when it happens, where it happens. But sometimes you want your error to bubble up and just just do something with that on your just more recent colors. So, and that's more tricky, but it wouldn't fit in a single slide. But that's the idea. And another thing where just using plain callbacks is kind of hard is when you have to somehow filter your results. For example, if you want to create a subroutine that is asynchronous and just basically fetch a URL, and but it decodes JSON from that URL and returns you just a hash or just a value for that JSON. So here you can just do it inside inside the callback of the natural fetch URL subroutine, but it's kind of messy and for one side, and on the other side, it's just hard to reuse. Why did you want to do that with multiple resources, not only URLs, but maybe, I don't know, data you get from a data store or something? So now let's go to the reason of this talk, which is how to just try to improve that situation. And what I'm just going to show here is these things called deferreds, or sometimes they call promises, or both, or futures. There are multiple names for this, but the concept is pretty much the same. So I'm just, for purpose of this talk, I'm just going to call them deferreds because I have a twisted background, and that's the horrible name that they choose for this thing. And deferred is basically something like this. This is a buzzer. I don't know if you have, when you go to a restaurant, sometimes they give you one of these. Some kinds of restaurants just give you this thing that you just keep it, and when your food is ready, it starts to buzz and just show some lines and something. And this is basically the promise or the defer. It's this token that they give to you, and they say, okay, we promise you that when your food is ready, we're going to just, that thing is going to start, is going to buzz. And you trust that. And that's the basic idea of a promise or a defer. It's just to materialize the concept of a callback into an object. So I'm just going to show a simple example. This is just JavaScript. I decided just to show how JavaScript in jQuery, the first in jQuery worked, because I saw that there's this Perl library called Promises, which is based on this common JS specification. So it works exactly as this. So the idea is just basically when you have your fetch URL function, instead of just accepting a callback, you basically return an object. And this object just has some properties that you can do with them. And basically, you just can attach callbacks to it. So you might say, first, this is not actually an improvement, it's actually worse. Because you're just getting an object, and then you still have to use the callback, and you're just still going to have the callback here. But the thing is, when you have an object that represents that promise, you can start doing interesting things with that. And we're going to see that in more examples. So, for example, one initial thing that you can do with that is just you can start adding some filters to your defers. So, for example, if you have a fetch URL, you can then pass a filter to indent it nicely if it's just so messy. And then you can pass another filter to maybe parse it as JSON, which it doesn't make sense, but it's just for the purpose of the chart, or for the example. And once it's done, you can just you call a callback that just do something with the result. Now another example is just, let's go and see how to do just our example of making a boat in Minecraft with deferreds. So what we can do is just call the initial function that returns a deferred object, which has this then method, which accepts maybe a filter or maybe another deferred, another function that returns a deferred, in this case process would, and then you can just repeat the process. So here we just call the three things sequentially. We chop the tree, then we process the wood, then we build the boat. We can do this because build the boat just takes as argument the result of process the wood, and process the wood takes as argument the result of chop tree. And when the thing is done, we can just print nicely, okay, this is just great. Of course, we can just also pass our own functions just if you want to do something interesting with the values. So here in this version, instead of just passing the process wood directly, we just pass another function that logs, okay, wood's ready, and then returns the same function processing the value that we get. So here, we eventually start seeing some more just sequential process, and instead of having to jump for multiple positions and try to, we more or less are getting some sort of sequential programming in an asynchronous way. Now another interesting thing is just how to make the cake with jQuery. So here we have, jQuery has this function called when, and when basically takes multiple deferreds, and it just gives you another deferred, which will fire when all of these deferreds are done at the same time, which is basically what we need. So we get the one to get the milk, the eggs, the sugar, the wheat, and when all of them are finished, we then process to make the cake. So this is, here, just very small compared to our previous example, which is raw callbacks. And eventually, let's just move to the next slide. Okay. And the next thing that we can do is just try to handle errors somehow. One thing about deferreds is that they take two kinds of callbacks. One, in the case that things succeed, and the other one in case there's an error. And the successful one is the done method, and the failure is the failed method. So you can, if you're building, for example, the boat, you can, at the end, instead of just putting a callback when everything is done, you can put another callback when anything failed. So here we don't know exactly which of the three operations failed, but we just know that one of them failed. Because one good thing about the deferred objects is that they just bubble up the errors up to the last deferred call. And that's a pretty handy thing. Another thing that you can do is that you can add here, I'm just going to try to show you. Here, you can just pass failure handlers to a specific just part of the chain. So here, when you chop the tree, you do two things. One, process the wood, and that's what happens if this was successful. But if not, you just do another thing. And what you do here is just maybe chop another tree, and then then process the wood. And then with the result of that, you will just build the boat, and so on. So this is another just way of doing things. Of course, this is, again, starting to become a little bit messy, but this is much easier than just using plain callbacks. Now, final thing I want to just we're almost done, but the final thing I want just to mention is that one very cool thing that we can do with this kind of pattern is that we can use coroutines to spice up our asynchronous programming. And a coroutine, if any of you doesn't know what it is, well, just basically you have two subroutines or two routines that just run just side by side. You start with one, and eventually you yield the execution to the other one, and then you start executing the other one until you decide just to give back or yield back the control of the operation to the other, and so on. And this is something that comes from functional languages, and it's very handy for the synchronous world, because that's exactly what you have in a synchronous programming. You have this event loop which controls the input and output of your program, and you have the actual logic of your application. And what you're doing is just going back and forth from one to the other. Wait a second. So, a very simple form of coroutines that you find in some programming languages, in this case it's in JavaScript, but not the JavaScript that is in most versions of the browser, but in this new spec called ECLIPSE 6. It's a very fancy thing where you can basically build generator functions. And these generator functions are just some interesting way of using coroutines to iterate over lazy stuff. So for example, here you have a synchronous generator that every time it has these yield statements, and these yield statements basically return a value. And what the yield statement does is just basically gives the control back to the color function or the color context until the color context just decides to give the control back to the function. So in this case, you start with you call simple generator, so you go to simple generator and then you yield first. Then this returns the control to the color function, and you just print first here by calling next. And when you call next, you come back to the function and just do the same thing over and over. And the result is basically what you can see here. This is something that you can see in many programming languages like, I don't know, JavaScript, C#, Python, etc. Now, oops. So what is interesting about this is that you can just use it with your defers or your promises to basically convert an asynchronous function in some sort of code that resembles a synchronous program. So this is just a function using this interesting library called task.js, which basically use this kind of coroutines to make asynchronous functions. So here what we do is, to make the boat, we take the wood, which is a yield from the chop tree, and then we return the control to the event loop here you say, okay, wood just yield chop tree. Then we go back to the event loop, and once chop tree is ready, the event loop returns the control to the function and gives me the wood. Then the same process is repeated with process wood and with build boat. And we eventually see this is actually happening in two different parts of the code and just going back and forth. But here in the code we see like an asynchronous operation. And now this is for the case of a sequential thing, where you need one thing and then need the other one, and so on. But what happens when you can just make 3 independent calls and just get things in one state already? This is the case of the cake. This is the case of the cake. So here, for example, we have the yield function. We call it with the same when function that we saw before. And we tell to the system, okay, basically find the chicken, get the sugarcane, get the milk the cow, and harvest the wheat. And once all of they are ready, just return me a new deferred, which is the one that I yield, and then I get the ingredients. The ingredients is an array with all the results of all these defers. Then when I have all that ready, we can just make the cake. And this is a very simple and just kind of easier way of thinking about asynchronous programming. Another example is this is with Python, where it has even a cool thing is that you can also raise exceptions inside the same kind of structure. So if there is an error, you can just catch it like if it wasn't a regular exception at the end. This is basically the same code as before, but with a try except clause. So you can just control your exceptions in the way that you would control a synchronous sequential exception, and it's very interesting. And the final example it's in C#, and it's basically the same thing, but they in the latest C# they included this directly into the language. So they created a few reserved words like async and await, and it's basically the same, just the same mechanism. Just that here, you don't have this when function to aggregate multiple defers. So what you can do is just to get the defers without the await function, and then just wait for them sequentially, which doesn't affect the final result, because you already called them all. So when they're all ready, this final part is ready too. And finally, you can just make a new await call to make the cake and return the cake. And just as Python, you can just also put try and catch exceptions. Just try and catch exceptions here to do something if an error happens in one of these steps. Okay, and finally, another use of this is just greenlets, but I will leave that for another time, because that will probably require another presentation. This is what greenlets is just a Python thing, but it's similar to what Go routines are done in the Go language, which is another interesting thing for coroutines for asynchronous programming. But this is for another time, because yeah, it will take too much time. Finally, oops, this is a picture of Minecraft. Now that you learn how to make boats and cakes, so please, there's a booking level. And that's it.